My name is Mari Pihlatie. I'm a professor in environmental soil science at the University of Helsinki. Today I want to talk to you about soils and their importance to our well-being and climate change. At first, I will ask you to take a deep breath. Breathe in and breathe out. This is what a healthy soil does. Breathing in oxygen and breathing out carbon dioxide. And we can measure this carbon dioxide. We can measure all what the soil is breathing, or all what you're breathing. And you know that breathing is a dynamic process. The faster you run, the more you breathe. Also, soil breathing depends on many environmental factors like temperature or moisture, or the plants living on the soil. I will tell you more about how we measure CO2 and carbon dioxide. I'll tell you more about that, but now I first want to take you to why are soils important. Agricultural soils today are suffering due to soil deterioration. Soil quality is depleting, and this is due to the fact that soils are anymore not alive. They are not breathing as they should. Modern agriculture has depleted soils, depleted the native organic material, organic matter in the soil. Crop production has been so intensive that we have maximized the crop yields with fertilizer inputs and as big outputs as we can, without returning the organic materials back to the soil. This has slowly led to a situation that soils, the organic matter in the soil is decaying. And this is now seen in decaying crop yields. Soil, in a healthy soil, soil is a living laboratory. It's full of life. It's full of small creatures, bacteria, fungi, and small animals dwelling on the soil, decaying the organic matter, releasing carbon dioxide to the atmosphere, and also releasing nutrients for the microbes and plants to grow in. Organic matter is a pool of nitrogen, pool of nutrients for the plants, and it's also a place to store nutrients from fertilizers. It also can bind water, which is important for living of plants and all creatures. When we are losing organic matter in the soil, we are losing this capacity of binding nutrients and water. And this is the reason why crops are now decaying. Soils are also facing another global crisis today, climate change. Climate change is also threatening food production, and this food production and climate change are interlinked. In warmer climate, decomposition of organic matter can be even faster, decaying organic minerals, organic matter faster from the soil. Now agriculture is also seen as a potential solution to mitigate climate change. And how is this? We know that it's not anymore enough to decrease greenhouse gas emissions from human activities, but we also need to enhance and increase sinks of carbon to ecosystems and oceans. And agricultural soils, they have a huge potential of absorbing carbon into the soil. So what we have lost to the atmosphere, we can take it back to the soils. But how do you do that? And how easy is it? Globally, agricultural soils are losing carbon. So how can we change these losses of being a source of carbon to a sink of carbon? There are multiple climate-smart agricultural practices that are now suggested to maintain, to increase the carbon sink to agricultural soils. And these include activating the plants, activating the carbon uptake from the atmosphere through photosynthesis to the roots and to the soil. Adding carbon compounds, using organic fertilizers, adding carbon to the soil to bind more nutrients and to keep the carbon there. And thirdly, to minimize the carbon losses. So minimizing disturbance of the soil, minimizing plowing and tilling. To keep the carbon that has been put there, to keep the carbon there and allow for the microbes and the structure in the soil to create a system where carbon stays. There are multiple open questions here with science to solve, and we lack verification of these tools. These are new tools. They are tools from thousands of years back, but they have not been verified. So what are we now doing? We are measuring the climate impact. We are establishing research stations around Finland to quantify the greenhouse gas exchange of agricultural fields, testing these climate smart practices, how they function. This is not an easy task because soils differ. Soil might have different amount of organic matter originally. They have different mineral composition. They have different nutrient level. They have different structure. They have different hydrology. And they all might react differently to these practices. So we need measurements and we need long-term measurements. We also need everyday measurements and continuous measurements because like breathing in and out of ourselves is dynamic. Also breathing in and out from the soil is dynamic. It's affected by changes in climate, by temperature, rainfalls. All these need to be quantified. And we need that information to understand what is the effect. Where can we get the biggest impact? What can we do to mitigate climate change? And what is good in these tools that if we can mitigate climate change by increasing carbon in the soil, we also improve fertility of the soil and crop production. There are many open questions with the dynamics of adding carbon to the soil. How does it affect other nutrients? How does it affect other greenhouse gas formation or uptake into the soil? We don't know exactly what happens in nitrogen cycling. When we add carbon in the soil, we also add nitrogen. And part of that nitrogen can be then emitted from the soil as nitrous oxide emission. Nitrous oxide is a strong greenhouse gas. It's 300 times stronger than carbon dioxide. So if we add more nitrous oxide emission from the soil, that can have a drastic impact on the climate. And we're working on this. We measure all the 3 greenhouse gases together day after day, year after year, so that we understand how do our winters, for instance, affect. How does possible warmer winters with waterlogging, how does it affect the climate? And how the snow cover, what happens then? We need these long-term measurements in order to get scientific understanding to the level where we can say that these management practices have this big impact. In science, we also have many smaller questions, basic questions that we are dealing with. We don't know exactly how can we make the carbon stay long in the soil. Is it the microbes, the dead microbes, that can fight against decomposition? Or is it just any organic molecule that's bound chemically to the mineral surfaces of the soil? These are big questions in the scientific community that we are solving and working on today. So I want you to remember now that soils are important also to mitigate climate change. They might be a big part of the solution, and we, with agriculture, we can work with them. Our work is also needed for decision making, and we want that decisions are made based on scientific understanding. Thank you very much.